सम सर सुनिए जी, कहिए। एक डाउट था, एक बार इधर आइए ना। नहीं, अगर मैं वहाँ जाऊँगा तो आपका जो डाउट है वो हम दोनों के बीच में सीमित रह जाएगा, मगर आप वहाँ से अगर ऊंची आवाज़ में अपना डाउट बोलेंगे तो हो सके कैमरा के इस पार जो है उनको भी थोड़ा बेनिफिट मिल जाए। वचन एक, बेनिफिट अनेक। वो जो प्रॉब्लम दिया था ना होम असाइनमेंट, वो सॉल्व नहीं कर पाए। So, in today's lecture number 9, we will discuss the problem given in lecture number 8 as home assignment, and we will discuss some more concepts of three-dimensional geometry. So, learn it, feel it, and enjoy the beauty of three-dimensional geometry. Hello YouTubers, कैसे आप सब लोग? Hope you are doing well. So, before starting today's lecture, lecture number 9, I want to wish a very happy Teachers' Day to all of my respected teachers, from whom I have gathered so much knowledge so far. आज भी सीख रहा हूँ, बरसों पहले भी सीखा था। कैसे नाम लूँ, जैसे मैं मेरा 10th स्टैंडर्ड में टीचर लक्ष्मी सर का, 11th-12th स्टैंडर्ड में आशीष सर केमिस्ट्री पढ़ाते थे, राजकुमार सर मैथ पढ़ाते थे, देवब्रत सर फिजिक्स पढ़ाते थे, दिलीप सर बायोलॉजी पढ़ाते थे। उसके बाद जैसे मैं कॉलेज में गया, थोड़ा थोड़ा करके बड़ा हुआ, मुलाकात हुआ आनंदमय सर से, द डॉन ऑफ प्योर मैथमेटिक्स। मैट्रिक्स टेस्ट तो उन्हीं से सीखा था। असीम सर और प्रसेनजीत सर और बीएम सर तो थे ही। बीएम सर तो जैसे हम लोग का दोस्त ही थे। और उसके बाद जब मैं गया पौंडीचेरी, वहाँ पे मुलाकात हुआ पिल्लाई सर से, दुराईभल सर से, फ्रांसिस सर से, मैम फतिमा से। उसके बाद मैं जैसे बीएड करने गया, वहाँ पे मुलाकात हुआ रामकृष्ण सर से, अभिजीत सर से, मिलन सर, अनिर्बन सर, संतनी मैम। इन सब ने मिलकर एजुकेशनल साइकोलॉजी क्या होता है ये मुझे सीखने में बहुत हेल्प किया। और भी बहुत अच्छे अच्छे टीचर मेरे लाइफ में आए थे। सबका नाम आज इस वीडियो में नहीं ले रहा हूँ, नहीं तो वीडियो बहुत लंबा हो जाएगा, आप लोग बोर हो जाओगे। और उसके बाद वन पर्सनैलिटी हैज़ कम टू माई लाइफ, जिनका नाम तो लेना ही लेना है, सतीश सर, माई प्रिंसिपल सर। ही हैज़न्ट टॉट मी मैथमेटिक्स, बट he has taught me how to teach. He has directed me and taught me how to deliver what I have acquired so far in this tank to the students. So, आप सब आज का वीडियो देख रहे हैं कि नहीं पता नहीं, मगर अगर देख रहे हैं तो मेरा नमन लीजिएगा, प्रणाम लीजिएगा, और आप सबका आशीर्वाद मेरे ऊपर बरकरार रखिएगा। It means a lot to me. Thank you. So the home assignment is find the vector equation of the line passing through the points -1, 0, 2, 3, 4, 6. So in lecture 8 we have derived the Cartesian form. Here we will find the vector form. So the vector equation of the line passing through two given points whose position vectors are a vector and v vector is r vector minus a vector equal to lambda times b vector minus a vector, because it was the diagram. This is point A, this is point B, this position vector is a vector. We have learned this in lecture 8. This is B vector. This is arbitrary point P whose position vector is R vector. Then we have derived that AP vector. P is a line, a point on the line L if and only if AP vector is parallel to AB vector. That is AP vector and AB vector are collinear. So AP vector can be expressed as some scalar multiple of AB vector. So here from here r vector minus a vector equal to lambda times b vector minus a vector. This is a small recapitulation of the theory what we have learned in lecture 8. Okay, so r vector minus a vector. So here a vector equal to say minus 1, 0, 2 are the components. So a vector equal to say minus I cap plus 2 k cap, and b vector equal to say 3 I cap plus 4 j cap plus 6 k cap. So therefore putting the values of a vector and b vector, r vector minus I cap plus 2 k cap plus lambda times b vector minus a vector means 3. See here we are considering the notes what we have discussed in earlier chapters, right, earlier lectures, right, that if b vector is equal to 3 I cap, 4 j cap, 6 k cap, then 3, 4, 6 are the direction ratios of b vector. 3, 4, 6 are components of b vector along x axis, y axis, z axis, and 3, 4, 6 are projections of b vector on x axis, y axis, z axis. So this point 3, 4, 6 we have considered here as b vector, and this point minus 1, 0, 2 we have considered here as a vector. So b vector minus a vector means 3 minus or minus 1 means 4 I cap. I think you have understood. Plus b vector minus a vector means 4 minus 0 means 4 k cap, plus again b vector minus a vector means here this is b, this one is say b vector, this one is say components of a vector. So here 6 minus 2 again 4. Here I have done one mistake, it will be j. Okay, 4 I cap, 4 j cap, and 4 k cap. So this is the required vector equation of the line. Now you can take this portion to that right hand side. It implies r vector equal to minus I cap plus 2 k cap plus lambda times 4 I cap plus 4 j cap plus 4 k cap. So this is the required vector equation of the line, where lambda is a non-zero scalar. Mention it in every problem, where lambda is a belongs to R, lambda not equal to lambda not equal to 0. This question is for diagram, rough work you can say. Okay. Now we will go to the next slide and we will learn a beautiful concept of three-dimensional geometry, angle between two lines. Next, here. So how we can derive, say these two lines in space. So how to derive the angle between them? So these two lines are not passing through origin, right? Now we have learned in earlier lectures that two parallel lines have same set of direction ratios, two parallel lines have same set of direction cosines. We have learned in lecture number 1. So my humble request to you, to understand all the concepts very easily, you have to go through sequentially. So you have to first go through the lecture 1, 2, 3, 4, 5, then come to this lecture number 9. Okay, then you can get all the concepts very easy. So now here the two lines are there in three-dimensional space. Now to derive the angle between them, here these two lines are not passing through origin, right? Now we draw two parallel lines, means two lines parallel to these respective two lines which are passing through the origin. Now as the two parallel lines have same set of direction ratios or direction cosines, so the direction angles are also same. So then we consider the two new lines which are passing through origin and parallel to this red line and blue line. Then we can very easily find the angle between these two lines. Let's see the diagram and check the theory. Okay. So first, let the equation of two given lines be r vector equal to a1 vector plus lambda times b1 vector. This is line number 1, say, and r vector equal to a2 vector plus mu times b2 vector. This is line 2, say. Now first we see the diagram. Here this is x-axis, this is y-axis, this is z-axis. Now first we take these two lines. Now from this line I draw a line parallel to this line passing through the origin, and take another line, say this one, now again I take another parallel line to this white line, say this one. Now the angle between these two lines means we name it as line 1, line 2. This one parallel, red one line parallel to this is L1 dash, say, and the line parallel to this white line L2, say L2 dashed. Now the angle between L1 and L2 is same as the angle between L1 dashed and L2 dashed. Say the accurate angle is theta. Okay. So now from these equations of the lines, we have studied the theory of how to obtain the equation of a line passing through a given point and parallel to a given vector. So this b1 vector, line 1, means this line 1 is parallel to b1 vector, and this line 2 is parallel to b2 vector. Take another color. Okay, this is say b2 vector. Okay, this is a b2 vector. So angle between b1 vector and b2 vector are nothing but the angle between line 1 and line 2, and again this angle is same as the angle between line L1 dashed and L2 dashed. I think you have understood. If any doubt is there, please rewind the lecture, rewind the video, go backward and again watch the video. You can understand the concept very easily. Nothing is there. So from scalar product of vector, so again I am saying that in three-dimensional geometry, concept of the vector chapter are very important. To understand all the concepts of three-dimensional geometry, first you have to learn all the concepts of vector chapter. Okay, I will cover vector chapter later. Okay, so b1 vector dot b2 vector, that is the dot product of b1 vector b2 vector equal to b1 vector magnitude b2 vector magnitude cos theta. So cos theta equal to b1 vector dot b2 vector by b1 vector magnitude b2 vector magnitude. So this will give the angle between the lines, given lines. So what are the values? We know Now you can go to the next page. Let direction ratios of B1 vector are A1, B1, C1, and direction ratios of B2 vector are A2, B2, C2. So therefore B1 vector equal to A1 I cap, B1 j cap, plus C1 k cap, and B2 vector equal to A2 I cap, B2 j cap, C2 k cap. Okay. Therefore, from previous page, what is the value of B1 vector dot B2 vector and B1 vector magnitude, B2 vector magnitude? We just put it simply. So cos theta equal to, therefore cos theta equal to A1 A2 plus B1 B2 plus C1 C2 by root, here the magnitude sign, by root magnitude of B1 vector means A1 square plus B1 square plus C1 square, and root A2 square plus B2 square plus C2 square. Take both side magnitude. This is the required angle between the two lines. Name it as 3, relation 3. Now from here we will derive the value of the angle in terms of sin theta. Okay, how to derive? Again goes to the next page. Sin theta equal to, we know that 1 minus cos theta, square root of 1 minus cos theta. Put the value of cos theta from the previous page, equal to root 1 minus, what is the value of cos theta? It is square. So A1 A2 plus B1 B2 plus C1 C2 whole square by, see from previous page, this square root will go because we take the square. So A1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square. Now we just simplify this equation. Square root of A1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square minus A1 A2 plus B1 B2 plus C1 C2 whole square by A1 square plus B1 square plus C1 square, A2 square plus B2 square plus C2 square. If we simplify this, we can get, if we here we use A plus B plus C whole square formula, and here we just multiply these two things, and if we simplify, what we get is root take the big root. Okay. I will give one easy step how to remember this formula. Short trick to remember this formula. Okay. So here A1 B2 minus A2 B1 whole square. First we go take the combination of AB. Then we take the combination of BC. Okay. plus b1 c2 minus b2 c1 whole square plus, then we take the combination of ca, so c1 a2 minus c2 a1 whole square by the same thing, a1 square plus b1 square plus c1 square, a2 square plus b2 square plus c2 square. Whole thing is under square root. Okay. Now here is the simple way. Have you understood this? AB. First we take the combination of AB, A1 B2 minus A2 B1 whole square plus, then go to BC. Take this, see this arrow, BC, B1 C2 minus B2 C1 whole square, then go to CA, C1 A2 minus C2 A1 whole square. So this is the easy way to memorize the formula. Okay, short trick you can say. So go to the next page. So this is the angle between the two lines in sin theta form. Okay, name this as relation 4. So go to the next page. Therefore, relation 3 and 4 will give the angle between the given lines. Now we will arise two particular conditions when the two lines, that is again this red pen and blue pen linked lines, you can say here. So if the two lines are perpendicular, then one particular case arise. Again these two lines may be parallel, then another particular case arise. So if two lines are perpendicular to each other, then the angle between them is theta equal to 90 degree, and if two lines are parallel to each other, then the angle between them is 0 degree. So we'll use simply this relation 3 and 4 to get a particular formula for that. Okay, so if not, take the note. Note 1. Okay, change the ink color. If the given lines are perpendicular to each other, then theta equal to 90 degree. We know that okay, sine 0 equal to 0, sine 90 equal to 1, but cos 0 equal to 1, but cos 90 equal to 0. We know that. So here cos 90 equal to 0. Here from relation 3, I think, previous page. Sorry. Here we put cos 90 equal to 0. So from this relation 3, we can see if this left hand side is 0, then what we will get? A1 A2 plus B1 B2 plus C1 C2 equal to 0. This is the particular case. So by cos 90 equal to 0, we write from where? Relation 3, A1 A2 plus B1 B2 plus C1 C2 equal to 0. This is one particular case. If two lines are perpendicular to each other, their direction ratios are given as A1 A2 A3, A1 B1 C1 and A2 B2 C2, then the relation is A1 A2 plus B1 B2 C1 C2 equal to 0. Now आप लोग सोच सकते हैं, पूछ सकते हैं कि ये कहाँ पे काम पे आएगा. अगर if there is in the exam someone asked as an MCQ question to check whether two lines are perpendicular to each other, in that problem if direction ratios of the two lines are given, then you can simply just check by this formula A1 A2 plus B1 B2 plus C1 C2 equal to 0. If this value is 0, you can just easily say that the two lines are perpendicular, and then you can just answer it within no time. Okay, so go to the note 2. Next page. Sorry. Okay, note 2. If the two lines are parallel to each other, then angle between them, that is the angle, acute angle between them, is 0 degree. Again, sine 0 equal to 0. As sine 0 degree equal to 0, by using relation what? Relation 4. Using relation 4, we will go to the previous page again. Here sine 0 equal to 0. So this square root value is 0. So this is numerator, this is numerator, this is denominator. Now this term will be 0. So a1 a2 whole square plus b1 c2 whole square, this term is 0. So go to the next page. So a1, again we will write a b c. This is a short trick, as I have said, to remember this term. So a1 b2 minus a2 b1 whole square plus, then take the combination of b1 c2 minus b2 c1 whole square plus, then take the combination of c1 a2 minus c2 a1 whole square equal to 0. But this what implies what? If a square, we use if a square plus b square plus c square equal to 0, that implies individually a equal to b equal to c equal to what? Equal to 0. So implies from here a1 b2 minus a2 b1 equal to 0, b1 c2 minus b2 c1 equal to 0, and c1 a2 minus c2 a1 equal to 0. As they are all 0, so from here we can say, we go to the next page. Okay, so a1 b2 minus a2 b1 equal to 0 implies, from here see, a1 b2 minus a2 b1 equal to 0. Next page implies a1 b2 equal to a2 b1 implies a1 by a2 equal to b1 by b2. So another interesting relation is coming of this byproduct, okay, of this theory. From this relation b1 c2, next b1 again, b1 c2 minus b2 c1 equal to 0 implies b1 by b2 equal to c1 by c2. Again, from the last term, that is this one, c1 a2 minus c2 a1 equal to 0 implies c1 by c2 equal to a1 by a2. So by using these three relations, this one and this one, by combining those three we can get a1 by a2 equal to b1 by b2 equal to c1 by c2. This is another again interesting relation between the direction ratios of these two lines when the lines are parallel to each other. So in the exam, if someone asks, check to whether the two lines are parallel to each other, where direction ratios are given, then you just simply check by this formula and answer the question in no time. So thank you for this today's lecture. We will see the application of this today's theory in next lecture, lecture number 10, because if we show the application in this video will go too long. ओके, सो आज एक ही दिन में सब कुछ देखने को नहीं मिलेगा। थैंक यू।